Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to talk about the last section in Chapter 4, Section 5, Systems of Linear Inequalities. It's going to be very similar to graphing linear inequalities, however we will do two at a time. So our first example, we want to graph the system y is less than 2x minus 3 and 2x plus y is greater than 2. Now, the first thing that I'm going to do is rewrite the second inequality in slope-intercept form. So I'm going to move the 2x to the other side, where it's going to become a negative 2x. Now, remember the golden rule of inequalities. Anytime you multiply or divide by a negative, you got to flip your symbol. I didn't multiply or divide by a negative, so I'm going to keep this as a greater than inequality. Now that I have my two inequalities both in slope-intercept form, I'm going to graph them one at a time. So the top one, y is less than 2x minus 3. I'm going to start at a y-intercept of negative 3 and count my slope. Up 2, right 1, up 2, right 1, up 2, right 1. And then I'm going to connect these with a dashed line because we are less than. Now, with systems, I shade very, very lightly because when I graph an inequality system, I want to really darken the area where they both intersect, where they both are shaded. So this is y is less than. I'm just going to lightly go that way just so I have an idea of which way it's going. And now I'm going to graph my other inequality. Y is greater than negative 2x plus 2. So I'm going to start at 2. And then count my slope negative 2. Down 2, right 1. Down 2, right 1. Down 2, right 1. This one will also be a dashed line because it was greater than. And then lightly shade, I would be shading above because we're greater than. So if I look where my red and blue shadings intersect, this would be the consistent area between my two inequalities. So this is what I would use as my solution, this area where the blue and the red intersect. These are the points that would work in both of these inequalities. Our next example, what is the graph of the system? Y is greater than or equal to negative x plus 5. Negative 3x plus y is less than or equal to negative 4. First thing I'm going to do is rewrite the second inequality so it's in slope-intercept form. I'm going to do that by adding 3x to the other side. This would be y less than or equal, at no point did I multiply or divide by a negative, positive 3x minus 4. Once I have my two inequalities in slope-intercept form, I'm going to then graph them. So let me start with the top one. Y is greater than or equal to negative x plus 5. I'm going to start at 5 on my y-intercept, and I'm going to count my slope of negative 1. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. And then I'm going to connect these with a solid line this time. Sorry that my line's a little curvy. And then this says greater than or equal. That means I need to shade above, and I'm just going to lightly shade because I also have another inequality to graph. Once I graphed my first one, let's do the second one. Y is less than or equal to 3x minus 4. I'm going to start at negative 4 and then count my slope 3 over 1. Up 3 over 1. Up 3 over 1. This one's also a solid line because it's or equal to. And this says y is less than. So I'm going to need to shade below this line. And where those red and blue lines intersect, where my shading is occurring at the same time, that's the area I'm really going to darken because these are the points that are solutions. So right there where the red and blue were both happening. All those points in the black area are solutions to these inequalities. So now I'm going to take a look at writing the system of inequalities from a graph. So we're going to look at number 2, problem 2. What system of inequalities is represented by the graph below? And we want to take these two lines, the dashed and the solid, and write our inequalities for each and come up with the system. So what we're going to do, we're going to first pick a line to start with. I'm going to start with this solid line. And what I'm going to do with this solid line, I'm going to pick out the y-intercept. I'm going to pick out the slope. So the y-intercept, the spot where I cross, would be at this point, right there, on the y-axis, and that would be 1. My y-intercept is 1. Now I need to figure out my slope. So I need to pick another spot where I cross good. I see a corner up here, and I see that I'm rising 1, and I'm running 2. So my slope would be 1/2. So I have a y-intercept of 1, a slope of 1/2. So if I write my inequality, I have y. I'm going to leave the space for the inequality symbol. My slope, 1/2 times x plus 1. Now I'm going to go fill in my symbol. This was a solid line, so I'd use an or equal to. And if I think about the way this one was shading, there's some shading going on below the graph. So below the graph, that would mean that this is less than. So my first inequality is y is less than or equal to 1/2 x plus 1. Once I have that first inequality, then what I need to do is go back through and write my other inequality. That's going to be with the dashed line this time. So if I take a look at my dashed line, let's do that one in blue. I'm going to go through the same process. With my y-intercept, where we cross the y-axis, that is also at 1 for the dashed line. And then count my slope. I'm going to go from the y-intercept to this point on the x-axis. So going down 1, right 2. This would be a negative 1/2 for my slope. So when I go to write this inequality, I'm going to have y. And then I have negative 1/2 x plus 1. And if I try to figure out where this one has been shaded, this one also has been shaded below the line. So if I'm shading below the line, it's less than. There is no equals to with this one because it was a dashed line. So my system of inequalities would be represented by these two inequalities right here. The last example we're going to take a look at is number 3 from problem 2. We're going to figure out the system of inequalities that's represented by the graph. So the first thing that I'm going to do, I'm going to write my inequality for the blue line, the solid line. So I'm going to figure out where it's crossing the y-axis. That'll be right here at 4. So the first line, b equals 4. And then I need to count my slope. So I'm going to count from this point to this point. It's going down 1, right 1. That would be negative 1 for my slope. So if I write the inequality, I have y, leave a space for the inequality, negative 1x, or just negative x to keep it simplified, plus 4. Now what I want to do is put in my inequality symbol. Since this was a solid line, I need an or equal to. And if we think about the way this one was shaded, in order to have this area shaded, we had to have shaded above the line. Anything shaded above means it was also greater than. So we have y is greater than or equal to negative x plus 4. Sorry about my greater than symbol. Make sure yours is pointed. Now, once I have the first inequality, I'm going to go back through and figure out the next inequality. So we're going to look at the dashed line next. And with the dashed line, we're going to do the same process. We're going to figure out where did we cross the y-axis. That'll be right there where I just somewhat circled at 3. So my b value is 3. And what is my slope? So I'm going to count from my y-intercept to the other point I just circled. Going up 2, right 1. So up to right 1 would simplify to 2. So when I write this inequality, I'm going to have y. I'm going to leave a space for the inequality symbol. My slope is 2x plus 3. Now, since this is a dashed line, there is no or equal to, it's strictly less than or greater than. In order for this shading to work out, everything had to have been below. Below means less than. So we have our two inequalities. Y is greater than or equal to negative x plus 4. Y is less than 2x plus 3. This concludes our lesson on being able to write a system of inequalities and graph a system of inequalities. If you have any questions, please ask Miss Brooks. Otherwise, we'll catch you next time on your Daily Dose of Math with Miss Brooks.